Okay, so now I'll be presenting my big data analytics project on personal health monitoring and analysis. So I've already run and saved the notebook so that it is easier for me to display the demo. Otherwise, it could become difficult to give the demo because it will take quite some time to run. So just a short description of my project. So first, what I'll be doing is generating health data, predicting number of calories burned daily based on features like height, weight, water intake, number of steps walked, etc. Then I'll be training a regression model on this data to be able to calculate the number of calories burned for some new test data. I'll be training a classification model for assessment of risk category based on some health features taken as input and predicting the risk category on test data. And I'll be training a classification model for predicting whether the person will suffer a stroke in the near future based on certain health parameters like age, prevalence of hypertension, heart disease, glucose level, and so on. So now, after doing some feature engineering and training a classification model to predict if a person has sleep disorder like insomnia or sleep apnea, this model is also used on test data to make predictions. So as the dataset used in the step 5, it is too small. I generate a similar dataset with more data points to improve the accuracy and recall of the model and to be able to make better predictions. Classification models are then trained on the generated data and we can observe better performance. So I also have included some plots of performance and some plots for exploratory data analysis. And the conclusion is that after getting the appropriate test data with all the required features, the models I'm going to train, they can predict the number of calories burnt each day, assess the risk category of a patient, check the likelihood of a person suffering a stroke, and also assess the presence of sleep disorders. So these models together, we can use them for personal health monitoring and analysis of general health. So for the first function, this just generates a normal distribution with mean, standard deviation, and two seeds there as input. So what it does, it uses the Box-Muller transform. Then there's a basal metabolic rate which is used for finding the base level of calories burnt each day. So this is the number of calories the person will burn even if he doesn't do any exercise. So this function is used to add some noise. Otherwise, the data, if I just simply generate the data based on a formula, then it will become too accurate. So, and real life data always has some noise, so I will be adding this noise. So now this function is used to generate data. So there is a date range. First I find the basal metabolic rate, the number of calories which are burned for sure. And there are some parameters for the number of steps, mean, standard deviation, the sleep, water, speed, etc. And then I generate the data frame and I add the noise. Now this function is used to add the data. So again I have some mean and standard deviation for heights, weights, and ages as well, of the age of the general population, the mean and standard deviation of that. Then I also assign the gender randomly based on a uniform random variable, and then I construct the data and return it as a list of parameters. Then I create the data based on the list of these parameters, and I have also saved the data and loaded it in here. Okay, this data has 9 lakh rows. Now the next part of the project is going to be fitting various models to predict the number of calories burnt. So I'll be using the Spark MLlib for this. So first I have to obviously use the vector assembler and transform the various features all into one feature. Then I'll be dividing it into training and testing data, splitting it 80-20 with a seed of 42. This function is used to evaluate the model on evaluate the linear regression model, and this function is used to plot the predictions. So I generate a test data with 90 rows. I create the test data. Then like you can see that there are 90 rows here. Then I convert the test data into a Spark data frame. This is the Spark data frame. Now I use linear regression to predict the calories burned. So we can look at the characteristics of the model. So you see that the RMSE is 21.93 and R squared is 0.98 with percentage error of only 1.06, and on the test data it is the R squared is 0.984 and the root mean squared error is 21.92 and a very similar percentage error on test data, so we can confirm that there is no overfitting. And now we can plot the predictions and we can see a fairly decent prediction. Now using the decision tree regressor, the error is around 3.75%, which is quite a bit worse as we can see from the plot as well. Then I use gradient boost regression where the error is 48.52, which is a little bit better. I also plot it again, which we can see is better than the decision tree, but it is worse than linear regression. Now I am using random forest regression, where the error is 2.37%, and I plot. So clearly the best model is linear regression. Now what I will do is I will generate one more data, and I will evaluate the linear regression model on it. So after generating the data and converting it into Spark data frame and plotting, we can see that the predictions, even for the new data, they are very much in line with the ideal. And now I'll be plotting some of the variables of the first data set, like water intake, calories burnt over time, steps over time, etc. So we can see the plots which indeed confirm that the data is random. So now the next part of my project is going to be training a classification model to predict the risk category of a patient, whether the patient is at low or high risk of falling sick. So this is an application of Spark distributed database processing and MLlib. So I load in the data set, and I load in the schema, where we see that there's a variable of type timestamp. So I must like extract the hour, minute, second, and then the risk category is a string and the gender is a string. So I will have to carry out some string indexing operations as well. We find that the target variable has only like two types, distinct risk category, and there are around 2 lakh rows. So now what we do is we check for null values. When we see that there are no null values, we can go ahead with the string indexing operations for the gender and the risk category columns, and then we drop these columns after converting them into integer. And now the next part is to extract the hour, minute, second from the timestamp variable. So we extract that and we display, and then we drop this timestamp variable, and now I'll be fitting the model on the new dataset I have created, just printing the schema here to check indeed that all of the columns are either integer or double type. Now I divide it into training, test, and validation data, and then I fit some models. So first I fit the decision tree classifier, which we see has a pretty high accuracy of 0.989. Then we can see the precision recall and F1 score, which are all quite high, and then plot the confusion matrix, which is like this. We can see that there are very few false positives or false negatives. Similarly, for logistic regression, it is a little bit worse, accuracy of 0.821, which we can see the precision recall F1 score also are in that range, and we can see the confusion matrix here. Then the random forest classifier, which has a very similar performance to that of the decision tree, 0.989 again. And then we can see that weighted precision recall scores are also quite high, and this is the confusion matrix. Our gradient rule classifier also performs quite well with accuracy of 0.988, and the precision recall are also quite high, and there are very few false positives or false negatives as well. And support vector machine has accuracy of 0.817, and the confusion matrix is as follows. We can see that there are quite a few false negatives and false positives here, so we can plot the accuracy here, precision, and the F1 scores, and this is a summary of all the algorithms performance. And now we are going to use that GBT classifier as the best algorithm. This can vary a little bit because the accuracy of decision tree, the random forest, and GBT classifier are all very similar, so I'll be using the GBT classifier to test it on some testing data. So I'm going to, this is the function to test for risk, and we can return the predictions. We can see that the accuracy is quite high on the test data as well, and there are very few true or false positives. So there's another reason why I chose this classifier, is because we can see that it never predicts any false positives, which is quite a positive. So we can view the predictions in this way, the predictions it has made. Now the next part of my project will be to predict the likelihood of a stroke based on the features. So first of all, once again, I load in the data set, I look at the schema. I also check how many distinct types of certain columns are there, like 2 for hypertension, 2 for heart disease, 2 for ever married, 2 for residence type, but there are 4 types for smoking status. Okay, so now again I apply the string indexer on these columns. I print the schema and I drop all the columns which are of string type, and then I again carry out the vector assembler. I check for null values, and we find some null values in the BMI column. So there are 2 types of imputation I will be doing. One will be mean imputation, one will be the median imputation. So after I do that, notice that the null values are gone. Now I'll be splitting the two data into training and testing data. One is the mean imputed one is the median imputed data. I use the classifier. Notice the accuracy for decision tree 0.946. Confusion matrix is like this. Now I use the decision tree classifier on median imputed data. We notice very similar values. Confusion matrix is also almost exactly the same. So the type of imputation does not really matter here. Logistic regression has accuracy of 0.948. Confusion matrix is as follows. Again, on median imputed data, this is the accuracy 0.948. Once again, confusion matrix is like this. For the random forest classifier on mean imputed data, it is 0.948. Confusion matrix is as follows. Median imputed data, once again 0.948. Similar confusion matrix, again 0.946. And we notice that the weighted precision recall values are also quite high and very similar for all of the models. Finally, I plot the accuracy. We can see very similar performance for all the models. Now the final part of the project is going to be predicting sleep disorder based on some relevant features. So at first I'll be using a dataset from Kaggle, but after that I'm going to generate another dataset, because the dataset I'm taking from Kaggle does not have too many rows. So I'll be generating another larger dataset to be able to have better performance for our models. So I'm just going to be doing some data analysis here, just checking how many distinct values are there in each column. For example, in quality of sleep there are 6 types. We notice the dataset is quite small with only 374 data points. Sleep disorder has 3 types. This is the target variable. This is what we are going to predict. Occupation has several types as well. Blood pressure, you notice that this is actually this should be a continuous value, but they have it as a string, so we need to separate it into systolic and diastolic pressure. So I'll be doing that below. Notice that there are no null values, and what I'm going to be doing is that I'm going to be converting this blood pressure value into 2 columns, systolic and diastolic BP, and then I'll be applying the string indexer on all the string value columns, and then dropping the columns with string values, and then viewing the schema, just checking the values for physical activity level again and sleep disorder. Then we import the vector assembler and again split the data into train and test, and then I use the different classifiers. So our decision tree classifier has accuracy of 0.905. Confusion matrix is like this, with pretty high values for precision recall and F1 score. For logistic regression also very similar accuracy. This is the confusion matrix with around 0.9 values for precision recall F1 score for that model. For random forest we see does a little bit better with accuracy of 0.929, and precision recall and F1 score is also quite high. For naive Bayes we see the performance is quite a lot worse with accuracy of 0.635. We plot the matrix for naive Bayes. It is like this. We notice pretty low values for precision recall and F1 score here, and now I'll be plotting the accuracy for the different models. Notice that random forest is quite a lot higher than the other models. Same for precision and for F1 score as well. So now the next part of my project is going to be to generate synthetic data of the kind being used above. So I have the list of occupations and BMI categories and such. So from the occupations I will be choosing randomly. For the gender also I will be choosing randomly, and for the BMI categories as well. For the rest of the values I'm going to be, for example, for the integer columns I'm just going to be using np.random.randomint to generate the random values, and for quality of sleep and physical activity level I'm going to be using a normal random variable. So then I take I create this synthetic data frame, and then I use a rule to define if there is a sleep disorder, and yeah, so I plot this is for plotting the variable. I generate the data, and for example I plot the quality of sleep, which you can see is quite random for different people, and you can take a look at the generated data as well, which once again you see it is quite random with the genders and the sleep duration and quality of sleep. So next I am plotting the physical activity level, which is again random. So I am saving this data in a file and then loading it back in, and this is the schema, and again we have to carry out a string indexing operations, drop the columns which have string values, Then I import vector assembler on this, and I split it randomly into a train and a test set. Then I train the classifier, and we see that the decision tree classifier, it has an accuracy of 0.979, which is higher than the 0.905 we had seen earlier. And the confusion matrix also, we can see that the precision and recall scores are all around 0.98, which is again higher than earlier. Logistic regression somehow performs a lot worse on this model with the accuracy of 0.694, and we can see similar values for precision recall F1 score as well. But random forest classified, it has an accuracy of 0.978, and precision and recall also of around 0.978. Naive Bayes also does quite badly on this model, with accuracy of 0.458, and precision recall and F1 scores are also quite low. So we can plot the accuracy and notice that decision tree and random forest perform a lot better here. Again, for same for precision and for F1 score as well. So now I'll be comparing the accuracy of the models trained on the Kaggle dataset versus the synthetic data, and notice that decision tree and random forest perform much better on the synthetic data. Same for the precision and for the F1 score as well. Now I'll be testing out the decision tree regression algorithm on some generated data. As we can see that it generally has the best performance. So once again, on the test data, I carry out all the string indexing operation, and then I evaluate it on the best model, which is the decision tree model, and then I'm saving this data and loading it back in, and we see that the accuracy on this data is 99%, 0.99, and weighted precision, recall, and F1 scores are all around 99, 0.99, and we can see that it has only misclassified one example. Of the 100 examples I have passed, it has only misclassified one example. So we see the actual and predicted values, and we see an almost exact match here. So in conclusion, I would just like to say that in my project, if we have the required data in the format of the models, then we can train the models, and we can test the users data on the models in order to get a lot of information about the user. For example, monitoring the calories intake over time, it can be useful for losing weight. Also, the stroke detection model, it can be used to warn people who are vulnerable to a stroke. Maybe they can have medicines or something of that sort. For sleep disorder patients also, we can use this model to diagnose whether the patient has a sleep disorder or not. And yeah, and that is pretty much it. Thank you for listening to my presentation.